Hello, let us try to understand the fundamentals of solar energy. But first, let us know that there are two kinds of energy, the non-renewable energy and the renewable energy. What is this non-renewable energy? Actually, these are the energy taken from the earth sources. When utilized, it will vanish 50 to 60 years from now. And also, it is impossible to regenerate it within a short period of time. It will take us great numbers of years to be replenished, and it is never an environmental friendly kind of energy, and also detrimental to the public health. And for the renewable energy, it is named as renewable because it is collected from a renewable resources. Renewable in the sense that it is naturally replenished on a human time scale. An example of this are the sunlight, wind, rain, tides, waves, and geothermal heat. Let's consider also the advantages and the disadvantages of this form of energy. For the non-renewable energy, the advantages or the pros are the following. It is very easy to use, just like filling up your car tank, and after it is filled, you power up your motor vehicle. Very easy. The gasoline or the oil is non-renewable energy sources. It is very cheap considering the nuclear power plant. The uranium-238 is just like a size of a pen, which is equated to 300 barrels of oil. So very cheap. It produces an amount of energy equal to the 300 or more barrels of oil. And also, it has a very limited competition. You'll notice that there were lots of gasoline stations in your place to fill up your car. And at present, considering the output, the mechanical power output, it produces high power output mechanically compared to the renewable energy. Okay, so for the disadvantage of the non-renewable energy is that someday it will expire and will be endangered resources, and also due to the speed of usage, and a lot of people is so dependent on this form of energy, it is giving us a serious environmental changes. The toxic gases that was released to the air when burned, when the fuel is burned, is the major cause of the rising temperature in the earth. It is what we call the global warming, and also the carbon emission is very dangerous to the people's health. Now, for the other form of energy, the advantages are the following. The source are abundant in quantity, and it is free, like the wind, sun, ocean energy, and the other. Also, considering the emissions, it is very low. The carbon is very low in percentage, and therefore it is considered as green and environmental friendly. Also, through this kind of energy, we can have a lot of jobs, and in the long run, our energy consumption will be cut off. And also, since that it has a low carbon emissions, it really promotes human health. The disadvantage of renewable energy is that the first cost is very high, and it also depends on the geographical location. So there are like the geothermal what do you call it, stocks. There are locations only that it is present. It's very dependent on geographical location. There are also places that is not windy, so the amount of wind that you need to harness cannot produce the mechanical power output that you needed to produce electrical power. So you have to go to a place where the wind is, the wind requirement that you need is present. And also it depends on time. An example of this is the solar energy. During the night, there are no solar energy because it only depends on the light of the sun, the exposure of the equipment to the sun. And sometimes it affects the natural flow and wildlife because we introduce equipment to the environment. And up to this moment, it is still on development to achieve efficient energy production comparing to the non-renewable sources. Now let's go to the photovoltaic cells or the PV cells. In the picture you see here is Edmond Becquerel. He is considered the father of solar panel. He is a French scientist. Actually, he discovered the photovoltaic effect in 1839. Photovoltaic effect is the process when light is absorbed by a material and creates electrical voltage. And most modern solar cells use, as of now, silicon crystals to attain this effect. So this is the silicon crystal. Now for the construction of our PV cells, there is a need for a doping. We have here the P or N-type doping. So what are these? For the N-type doping, it's actually when we say doping, we introduce the small quantities of material to silicon. For N-type doping, we use phosphorus and arsenic. Why? Because this phosphorus and arsenic have 5 outer electrons, and these electrons are out of place. So when they get into the silicon lattice, the 5th electron has nothing to bond to. So it creates a free electron to move around. It's just a very small quantity that you place on the silicon, or we call this as impurity. So it will create enough free electrons, and this free electrons is the one that we are using to create electrical current. It is named as N-type because electrons is a part in the atom that has a negative charge. That's why it is called as N-type doping. For the P-type or the positive charge type doping, we use boron and gallium. So this is our dopant. And when we place this into silicon, actually this boron and gallium have 3 outer electrons. So when you mix it in the lattice, silicon lattice, it actually forms holes. Okay, so the absence of an electron creates the effect of positive charge. Hence the name type is P-type. So here in the P-type, we are producing holes. For the N-type, we are producing a free electron. And then this is the picture of the doping. So this is the pure silicon. You see this blue here is the silicon nuclei. And for the N-type silicon, we introduce doping. So the phosphorus nucleus is in the red color. You will notice that there is a free electron here. And for the P-type, the green here is the boron nucleus. You see, we introduce here a hole. So this is the negative and this is the positive. This is the typical arrangement of our cells. So actually, these are the silicon that is doped, the N-type, and it has a bar here separating the two because this one, the under is the P-type silicon. So introduced here is a glass. So this is actually a non-reflecting materials to prevent rays from the sun, to increase the light absorption, to let it absorb more light. And also this is a non-scratch material to protect the photovoltaic cells. And there are conducting materials to collect the holes and the electrons. So sun rays and sunlight, which gives photons, this one, so this is the sun, and that's the typical picture of our cell. And we have the advantage and disadvantage of the PV cells. The advantages of this are it provides green energy, free and readily available energy, which is from the sun. It can be locally used, therefore reduce losses. So you don't need to introduce here a transmission or a distribution system. And it is very low in maintenance and cost. You just have it cleaned for the sunlight to get more light from the sun. And it is totally silent. Okay, so it has no moving part as compared to the other industrial plant like the geothermal power plant or the other plant which has a turbine. It has a moving part, but this one has no moving parts. But the solar tracker can have also a moving parts because it tracks the position of the sun, and it is very easy to install. And as of the present, it is already used in the outer space, since that the amount of sunlight there has no obstruction. Now for the disadvantages, during the night, since it is very dependent on time, during the night there are no power production, electrical power production. And also if it is rainy, if the weather is not sunny but rainy. The other system setup needs also a battery for the storage of energy and also an inverter. Now the efficiency of your PV cells is from 15% to 25%. It's very low as of now, but the scientists and the engineers are introducing a PV cells that is higher than this percentage efficiency as of now. And it needs continuous cleaning to remove photon blockade. Now for large power generation, if you want to generate a huge amount of electrical power, you need a large area for the solar cell. This one, you have the monocrystalline, the polycrystalline. You'll notice here that you have a rating here for the open circuit voltage, VOC, which it generates 0.625 for one solar cell. Maximum power is 0.5, maximum power current 8 ampere, maximum short circuit 8.5. The optimum power of this kind of cells is 4 watts. This is approximately 4 watts. Okay, so more on the cells, we have here the amorphous, then monocrystalline and the polycrystalline, which each cell is producing approximately 0.4 volts. So you have this one, and you can have a light blue color, the blue or the dark blue color. So the measurement is about 156 millimeters. This is shaped as a square. Now if you want to generate a 24 volt nominal power, you must have a 72 of these cells. Actually it will give you 28.8 volts. So, but since its efficiency is considered, that's why you need 72, more or less 72 solar cells. So this is how it is connected. So each cell is connected in series. So you have here the negative, positive, and it is connected to the other cells negative, and then connected in series. So these are cells connected in series. Okay, and then this is also the module. So it has the cells, lot of cells here. This is the cell. This is the connection of or producing a cell to array. So you have here a cell, and the cell is connected, and it is called now a module. and the module is connected and it is called a panel, and the panel is connected and it is called an array. Okay, so the solar cell, so in a string, so this is the cell, and when you connect the cells in series, it is called a module, and when you connect the module in series, it is called a string. Now, if you have here a module in series and connected in parallel, so this is called the array. So strings, this series module, which is a string, is connected in parallel here. So let's consider some facts about the solar energy. Number one is that solar energy is completely free source of energy. Okay, it is found in abundance. Actually, the sun is 90 million miles away from our home, from Earth, and it takes 10 minutes for light to travel from that much distance. The other one is that the solar technology can be distinguished into active and passive. Okay, so we have the photovoltaic panels and the solar thermal collectors. These are examples of active solar technology. For the passive one, you can consider the constructions of rooms to improve air circulation, or the orientation of the space in favor of the sunlight. So that is a passive technology. Okay? And for the number 3 fact is that the Earth gets 174 petawatts of incoming solar radiation in the upper atmosphere. About 30% of it is reflected back to space, and the rest is absorbed by oceans, clouds, and masses. By the way, petawatt is this value to the BTU per minute. Okay, it's amazing. Now, fact number 4 is that solar-powered hot water systems utilize solar energy to heat water. In certain areas, 60 to 70% of water used domestically for temperatures as high as 60 degrees Celsius can be made available for solar heating. So these are another types of utilization of your solar energy. It can also be used for potable water. I mean, making potable water. If your water is not potable, so you can use the solar energy system. Okay, so without using electricity or chemicals, wastewater can be treated. Creating salt from seawater is also one of the oldest uses of solar energy. For fact number 6, solar energy is converted into electricity by using either photovoltaic or concentrated solar power. For the photovoltaic, this is called the direct method, and for the concentrated solar power, this is indirect. Okay, so large beams of sunlight are focused on a small beam using mirrors or lenses in the case of concentrated solar power. So we have an example for that. And for the photoelectric effect, we use PV or photovoltaic to convert solar energy into electric energy. So again, solar chemical processes replace fossil fuels as a source for chemical energy and can make solar energy storable and transportable. So the technology for producing hydrogen is a major area of solar chemical research. Another fact is that solar energy can be stored also in molten salts. Another fact here, the Earth receives about 1,366 watts of direct solar radiation per square meter. So the largest solar power plant in the world, another fact, is that it is located in California, in Mojave Desert. It covers 1,000 acres. And another fact here, home solar panel system consists of several solar panels, an inverter, a battery, a charge regulator, wiring, and support materials. Sunlight is absorbed by the solar panels and is converted to electricity by the installed system. So the battery stores electricity that can be used at later time, like cloudy days or during evening or time when the sun is not available. For number 12, fact 12, solar energy is measured in kilowatt hour. So 1 kilowatt is 1,000 watts. Fact 13, solar energy is used in many applications including electricity, evaporation, biomass, heating water, and buildings, and even for transport. So this is a picture of what we call sun tracking panels, where the panels are, when the sun moves, it faces the sun. So we use a sensor for this case, and that sensor is connected to the motor for the sun to get the most efficient exposure of the panel to the light of the sun. Thank you so much.